Okay, reviewing and talking about inequalities. First off, inequalities, we need to remember that they are symbols like this. This symbol right here, opening up, reading from left to right, pointing to your right. What symbol is that? It is greater than. This one right here, less than. I would suggest before you take your test at the very top of the test, if you tend to find that you get these confused, or maybe you're afraid that you might have what I call a brain fart. It's kind of like where you're sitting there, you know all the material. How many times have you gone to take a test and you like, I know this, and you sit down and all of a sudden you see all these words and it's like everything just comes out your brain and you don't remember anything. And you have that blanked out. That sounded like a real fart too, didn't it? Okay. Anyway, that was just DJ. All right. So anyway, I would write at the very on your EOC test, you can write on your test. Right on the very beginning of it. Put in there greater than and less than. Okay, we'll talk about other things. With another thing I would put at the top of my test would be okay, the other thing I would put at the top of my test too would be independent and dependent. What's the independent variable? It is X. Dependent, Y. I would put that at the top of my test too to remind me. And there's other things I will talk about this that I'll talk about that we put at the top of our test. All right, but first there's greater than and there's less than. Another thing, if we wanted to talk about things with the inequalities, say that I had X is greater than 6. And I told you to graph that. First off, how many variables are there? There's one variable, okay? That's the x-axis. The x-axis is the horizontal axis. Remember on a graph, we have x is here, y goes up and down. Maybe that's something you need to write at the top of your test to help you remember. Now, when we do this and we go to graph it, it says x is greater than 6. How do I graph that? I will do a shading. I will shade, but before, what do I need to put at 6? Some kind of dot. It's got to be an open circle. Why do I not color it in? Because it's not equal to. See? And then it's greater than, so we shade to the right. Now, here's the thing. We all say to each other, oh, yeah, I know that. I know that. But it's a matter of reviewing and looking over this stuff to remember. Does that make sense? Like, just get your brain going, because in the next 2 weeks, you've got to get your brain going and remembering these things, because we know it. It's just a reminder. Okay? So when they ask you can you guys give me what is a solution to this inequality? Give me anything that's a solution. There's lots of different solutions. 8, and it's actually not 0, 8, because 0, 8 would be a y-intercept. 12 would be one. What were you telling me? 7. It's anything greater than. What if it was 6.1? Yes. What about 6? It does not say equal to. So 6 and less, those are not solutions. And on the test, the type of things they'll ask are points like 6, because they're going to test you and see, do you remember open dot and closed dot? Okay. We're going to have things like, I don't know, 7 is not 7, x. X is less than or equal to -7. So I've got the x-axis, and I draw my line here. Now, at -7, what kind of dot do I put here? A closed-in dot. Less than, I'm going to shade to the left. So now, is -7 a solution? Yes, because it's equal to. What about -7.5? Okay. I'm going to make a suggestion to you. A lot of times, where would 0 go on this number line? To the left or to the right? Okay, so 0's over here to the right. Now let's think about this. It goes -1, 2, 3, 4, 5, 6, 7, 8. So guess where -7.5 is? Be careful, because even though the numbers get bigger going, I mean, it actually doesn't get bigger. Like some people think of them getting bigger. Like it looks like they are, but really they're getting what? Smaller because they're negative. Okay? Now what about when we have things like x plus 2 is greater than negative 12? What do I have to do to solve this? I don't move the x, I move the 2. How do I move the 2 over there? I subtract 2 from each side, and I get x is greater than negative 14. Okay? So now, if I wanted to graph this, at negative 14, I would put an open circle or a closed circle. What would I do? Open. This symbol is greater than, shade to the right. Okay, that's a good point. Somebody said that the greater than symbol is like an arrow telling you which way to point. That is only true if the x is on the left-hand side. It could be written, this means the same thing, guys. Look at that. These two things mean the same thing, but they're written in different directions. So you have to know that if you're doing, you have to know what this is saying. Negative 14 is less than x. Now, you know, for me, that's why whenever we said to solve it, always put the x's on the left-hand side. It makes it easier. And then you can use the arrow for the way it's pointed. But if you flip it over, just like in a mirror, when you flip things over, the whole thing has to flip over. Okay, so be very careful because these mean the same thing. Okay, so another one that we have, let's see here. Let's go with negative 2x is less than negative 6. What would I do to solve this one? No adding the 6. What's next to the x? Okay, it says negative 2 times x. The opposite of times is divide. You will divide by negative 2. Ding, 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 ding. Why am I freaking out? You divided by a negative, so you have to flip it. And guess what? They're going to have that on the test because that's what they want you to know. And so it becomes this. Okay? Now, you go to graph this one. At 3, it is an open circle, and you shade to the right. Okay, another one would be that people get confused on, and I think maybe we just don't do work on them enough, is this right here. Look at this one. All right? What do we do here? People get confused because they see that divide by thing, but really, treat it the same way we have been. X divided by negative 6. What's the opposite of divide? Multiply. Multiply each side by negative 6. Ding, 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 ding. We still have to flip the sign. And I know that most of the time when we get in the habit of teaching it, we only say when you divide by a negative, but it's when you divide or multiply by a negative, you have to flip the sign. Somewhere in your paper, you may want to write down that when you multiply or divide by a negative, okay, by a negative, you have to flip it. Okay, so this becomes less than or equal to. So these cancel out, and I get x is less than or equal to negative 12. Entienden? Do we understand? Okay. Let's look at another one. Let's do here. Negative 10x minus negative 40 greater than negative 50. Okay. The first thing I notice is my parentheses. A negative times a negative is a positive. See, this, when you have two negatives, this is like negative 1. Negative 1 times 40. So this becomes negative 10x plus 40 is greater than negative 50. Okay? Now this is solving it like a regular equation. Subtract 40 from each side. You get negative 10x, because these cancel, greater than negative 90. Divide by negative 10. Ding, 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 ding. X. And flip it. Flip it. Whip it. Flip it. Okay, yes, I am losing it mentally. That is okay. All right. Clearly. Okay, so then solving inequalities and working with them, let's write up another example. We have 2x plus 1 greater than 3x. Now, on this one, I said that one of the things you want to make sure and have is your x's on the left-hand side. Okay, this kind of stinks because it's better if you move it over here to the right-hand side. So I'm going to do both ways here and kind of show you what I'm talking about. First off, if I wanted just to get the x's to the same side, one way you could do this is you could subtract 2x from each side. When you do that, these cancel and I get 1 is greater than 3x minus 2x is 1x. Well, that's great, but if you wanted to graph it, this may be more difficult to figure out which way. So I can also flip it over and rewrite it as x. Now look at the arrow. The tip of the arrow is pointing towards the x, right? So let's point it towards the x when we flip it over, and that's what these mean the same thing. Okay? Now, I could also solve it. It's just more steps. Okay, so I'm going to take the same problem, and I'm going to move my x's over here to the left. Well, there's a couple different ways. Let me do this. I'm going to move my 1 over here to the right, and I get 2x is greater than, because these cancel, 3x minus 1. Now move the 3x to the left-hand side. Subtract 3x from each side. 2x minus 3x is negative 1x greater than, these cancel, negative 1. Now right here, negative 1 times x, I would divide by negative 1. And ding, 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 ding. I divided by a negative. So you flip the sign. You see how you got the same answers? But the thing was over here, it's just less steps. But sometimes if this makes more sense to you, if we had to graph it, it's worth it to do all the steps, to do more steps. Okay, let's look at another one. Let's see here. Let's look at 4x minus 8 greater than or equal to 2x plus 6. Well, let's solve this one. Draw my dotted line. You don't have to do that. I only do that to make sure I know where I need to do the opposite, moving them across. I will move this 2x. I will subtract 2x from each side. And I get 4x minus 2x, which is 2x minus 8 greater than or equal to, these cancel, 6. Well, now what do we do? Add 8 to each side. You should get 2x greater than or equal to 14. Divide by 2. Do I flip the sign here? I don't, because I did not divide by a negative. So it's x is greater than or equal to 7. Okay, let's do one more. I have negative 10x plus 50 less than or equal to negative 20x minus 20. Again, I like to draw my dotted line right here. I'm going to add 20x to each side. Okay, I'm going to move my x's going to the left-hand side. So now, negative 10 plus 20, 10x plus 50, less than or equal to negative 20. From here, I'm going to subtract 50 from each side. I get 10x less than or equal to, well, negative 20 minus 50 is negative 70. Now I'm dividing by 10. Okay, do I flip the sign here? I do not, because that bottom number is not negative. So it is x is less than or equal to negative 7. There would be your answer. Okay, this has been our beginning review of solving inequalities.